Good day, everybody. Today we are going to talk about hypothesis test for the mean when the population standard deviation is not known. The following table represents the sample sandwich prices in US dollar for Europe. And there are a certain number of samples. Test the hypothesis that the mean sandwich price in Europe is less than 5.04. Use level of significance equal to 0.01. As we note, the sample size is less than 30. So we have to test that the sample came from a normal population. Okay, first part. Solution. Test that the sample came from an approximately normal population. Came from an approximately normal population. Normal population. How will we do that? We will enter the data in L1 of the calculator and make a modified box plot. Why modified box plot? Because that shows the presence of any outlier. Check for outliers. Check for outliers. For outliers. Okay. So first we have to clear the memories of the calculator. So we will do second button, then plus button on the bottom right corner on top of the enter button. Then number 4, clear all list, hit enter. Done. That means memories have been cleared. Then stat 1, enter the data in L1, which is 4.44, 3.15, 2.92, 3.96, 4.35, 4.51, 4.17, 3.69, 4.62, 3.80, 3.36, and 3.85. Okay. So now we want to make a modified box plot for this data set in L1. So we will press the second button, then the Y equal to key on top of it, and then select number 1, which is plot 1. First line should be flashing on. Second line type, it should be on the fourth, 1, 2, 3, 4. Fourth type of chart, which is modified box plot. Okay. Then we will hit the zoom button, which is the third key in the extreme top row. Zoom button and then 9. And we will get a box plot like this in our calculator screen without any outliers. This is the box, and this is Q1, this is Q2, this is Q3, and it is like this, and slightly a bit more extended. Let me clear that and make a better left whisker. So slightly longer whisker on the left-hand side. Okay, but there is no outlier. Had there been any outlier, it would have been shown by a box either on the right or on the left. No outlier. Okay, this is your minimum, this is your maximum. No outliers on the right or on the left. No outliers. Conclude that the sample came from a normal population came from an approximately normal population. Normal population. Okay. Okay. Now we have to calculate or we have to test the hypothesis that the mean sandwich price in Europe is less than 5.04. So, okay. Why did we do a box plot? We want to make sure that the sample came from a normal population so that we can carry with the hypothesis test, carry on with the hypothesis test. Okay. So let's write our null hypothesis is always equal to mu equal to 5.04 and the alternate H sub A is mu less than 5.04. Since we do not know the population standard deviation, therefore we will do a t-test. Since population standard deviation is not known, use t-test. Okay, so how to do this test? So we will use TI-84, which will calculate a test statistic, which is a characteristic of the sample. And then we will look for the p-value, which is the probability value of getting a test statistic as extreme as what we will obtain. So first thing, press the stat button. Then highlight test on the top row by moving the cursor on test and hit enter. So stat button, highlight the test button, hit enter. Okay, test, and then move the cursor. Okay, so let me reduce that a little bit. Okay, and move the cursor down. Oops, sorry about that. Okay. That test and move the cursor down to number 2, which is the t-test. Again, we are doing t-test because we do not know the population standard deviation. There's no outlier on the right or on the left. Okay, so we go down to number 2 and hit enter. Okay, input should be on data, first line, because we have entered the data in L1. So put the cursor on data and hit enter. Okay. What is my null hypothesis? Mu0 equal to 5.04. Mu0 is the hypothesized value in the null hypothesis. So mu0 is 5.04. List is L1, frequency is 1, okay? And what is my alternate hypothesis? That's in the 5th line. It is less than 5.04. I have told the calculator that my mu0, that is the value in the null hypothesis, is 5.04. Therefore, in the 5th line, I'll put the cursor on less than mu0 and hit enter so that it's flashing on less than mu0, okay? So list is L1. Okay, frequency is 1. And then I create some more space. The alternate hypothesis is mu less than mu0. So bring the cursor on less than mu0 and hit enter. So that is flashing on less than. And now we will calculate. Bring the cursor to from less than mu0 to calculate and hit enter. Okay. And the test statistic T is the test statistic. Remember, it's a characteristic of the sample that we have gathered is equal to 5.04. And the p-value is definitely not 9.17. It is 9.17. Whenever we have a p-value greater than 1, we should look at the right end, which says E minus 6. What does that mean? That means the first number, 9, is at the sixth place after the decimal. 4, 5 zeros after the decimal, and then 9. Okay. Compare that with alpha equal to level of significance of 0.01. This p-value represents the probability of getting a test statistic as extreme as 5.04. Now, alpha is 0.01 and p-value is less than alpha. So the decision is to reject H0. Reject H0. And conclusion, at alpha equal to 0.01, there is enough evidence to support HA. When we reject the null hypothesis, we support the alternate to support HA, which states mu is less than 5.04. Okay, so I will stop here today. If you have any question, comment, you can always write me a note. Just to summarize what I did, let me first clear this. So we'll go on this. Okay. I will then move up to summarize what I did. Let me see if I can move up. Give me a minute. Yeah. So we were given a table of data. We first proved that the sample came from a normal population. Then we tested the alternate hypothesis mu less than 5.04. We entered the data in L1 and we went for t-test. Why did we go for t-test? Because we do not know the population standard deviation. So after inputting the data, given data that is null hypothesis mu0 is 5.04, and we are testing for the left tail test mu less than mu0, and we calculate the test statistic, which is 5.04. This is a characteristic of the sample. The probability value of getting a test statistic as extreme as 5.04 is extremely small. It is less than alpha, which is 0.01. Hence, the decision is to reject H0, and conclusion is at alpha equal to 0.01. There is enough evidence to support the alternate. Okay, so I will stop here today. If you have any question or comment, write me a note. I will get back to you as soon as possible. And if you like this video, please give me a thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. This is because I solve all kinds of math problems every day. So please do not forget to watch me next time when I will be back with another problem, another solution. Thanks for watching. Take care. Have a nice day.